Hi, my name is Scott Grilliot, and I'm going over how I got the answers to the third exam, and these are going to be the explanations of how I got the answers and how these problems are to be solved. So I'll start with the first one here. The first question here is asking about, as you can see here, I'm just going to hold it up. So it's asking about these different attributes, and then it gives some different diseases, some syndromes, and it asks which ones are related to these terms here. So the first one is asking about Patau syndrome. And Patau syndrome, I went ahead and wrote it here. It's when you have an extra chromosome. And so because you have an extra chromosome, it would be related to trisomy, which is where you have a normal amount of chromosomes, except that one of your chromosomes is duplicated, so that there's 3 instead of just 2 homologous chromosomes. Non-disjunction was another term because that would have to take place. There would have to be an extra chromosome made during meiosis, which is called non-disjunction, and then aneuploidy because it's the normal amount of chromosomes plus 1 extra chromosome. So the next one asks about Down syndrome, and once again I wrote here that has to do with an extra chromosome, and so that would have to be trisomy, non-disjunction, and aneuploidy because it's caused by the same thing. And then the next one is Turner syndrome. So Turner syndrome is an interesting one. It comes from a non-disjunction meiosis, which causes somebody to have an X chromosome and no other sex chromosome, just an X. So no XX or XY, just one X. And so that actually is the same thing, except instead of trisomy, it is monosomy. Monosomy meaning it has 1 less chromosome than it would normally have. And then the last one, it's Kruti-Chat syndrome. And Kruti-Chat is the deletion of one of the chromosomes. And so that would end up having deletion and monosomy. So that was the first question there. And then part 2, here we go. So part 2, so I went ahead and wrote on the board here some of the primers. Hopefully you guys can see up here in the corner. And it gives you the primers, and then it also gives you a long strand of DNA here. You guys can, there we go, right there at the top. So that's a long strand of DNA up there. And as you can see, I found out where the primers are on each one. You see the primer there and a primer there. And then ask some questions about the primers. It says, indicate the polarity of the primers on the image below. And so primer A, it goes from 5' to 3', and primer B goes from 5' to 3' as well. And what that would mean is that the 5' end would be over here, and 3' end would be over here. Sorry, the blue should be what you see in blue here. This is actually the primer, and then what's in red is just the DNA code, just like you see here. So I wrote, here's the print of the primer, and then I wrote the code beneath, so that way I can be able to find the DNA code inside of here where the primer started. And so then after that, it asked what is the DNA sequence that will be synthesized between the primers. So after I was able to find the primers, I was able to find that DNA code by seeing what was in between the 2 primers, which is right here. And so I was able to write that down. And then ask what direction right to left or left to right is the replication fork moving as the daughter strand is being synthesized. So I said, because the strand is being synthesized from 5' to 3', and I kind of drew it out here, and we know that this is the lagging strand because there's 2 Okazaki fragments up here. I said that we have to know that the replication fork is moving to the left. And I didn't draw it so well on this picture. I actually drew it backwards, but after drawing that, I was able to figure it out, and I was able to realize that it was actually moving to the left, the replication fork. And then the last question regarding this section is which of these two primers was synthesized first. So the primer that's closer to the 5' end of the DNA strand was synthesized first, which is primer B, as you can see over here. And I said primer B because this one is closer to the 5' end, and the 5' end is where the replication fork will be moving away from. And so because the replication fork is moving away from the 5' end, the primer would have been able to be put there earlier. Hopefully that makes sense. So now question 3. Suppose that an individual is heterozygous for the following characteristics. Okay, so for that one, I actually drew it up here on the board, how I got the answer. So I went ahead and drew 2 chromosomes here. One of them is inverted, as you can see, and one of them is normal. And the inverted chromosome, it creates this little loop here so that the chromosomes can actually pair up on the homologous chromosomes, and the alleles will link up. And that way on this loop, you have W at the bottom and S at the top instead of reverse. So the 4 different allele compositions, the first 2 are just the parent alleles. Just what you see here on the top, and then what you would see here on the bottom, just going around this loop and then coming at the end. So LMN, OPQRS, TUVWX, and then little l, MN, OPQR, WVUTSX, because it had that inversion there. And then, let's see here. The third one is actually going to be, it's going to start from this end. Big X, big W, V, U. Then it's actually going to switch down to the bottom here. Little t, little s, little w, little x. And it'll switch over at this little place here where there's the crossover. And I drew that in red, the crossover. And then the other one is going to start from this end with the big L, L, M, N, O, P, Q, R, S, T. Then it's going to switch to lowercase letters here. And it's going to go to U, V, W, R, Q, P, O, L, M, N, or N, M, L. So that's how I got the answers to those 2. And then the last one here, the last question, is going over, I'll show you guys what I have here. It's going over a DNA molecule shown of E. coli, and it's showing the different, it shows where the +1 site is on the DNA molecule, and asks some questions about that. So it says, which strand, upper or lower, I'll show you, is the template strand, and which one is the coding strand? So the +1 starts with an A on the coding strand. That's always the case. So because of that, we know that this bottom strand is the coding strand, and then the top one is the template strand. What sequence of the mRNA molecule is produced from this DNA molecule? So I said 5' to 3', and it's going to create this. And I was able to figure that out by saying that I know that DNA will be synthesized on the DNA molecule from 3 to 5. So because of that, the RNA molecule is going to be 5' to 3', synthesized in the 3-5 direction on the DNA strand. And so I was able to say, okay, it starts at A and it's going to go this way, and then I was able to figure that out. In what direction, left or right, is the coding strand relative to the +1 site? Would the -10 and -35 regions be located? So it's going to be located towards the 3' end, and that's where the promoter regions -10 and -35 are actually going to be. And you're able to kind of see that I tried to square off the tautologs there, where DNA is going to initially begin to be RNA polymerase, and things along those lines are going to bind there and start the process of replication, or sorry, not replication, RNA synthesis. So in what direction, left or right, along the coding strand relative to the +1 site would the terminator be located? So I wrote that over here, and that's going to be on the right side, on the 5' end of the DNA molecule, or the 3' end of the RNA molecule. And so that's how I got the answers to all those questions. Hopefully that helped out. I appreciate you guys watching this, and you have a great day.